So good morning, my dear students. In this physics booster classes, on this second day, we'll be doing with an important topic by name atoms. Okay. In NEET 2026, recently over there was one question based on the atoms they have given. Generally, one to maximum two questions come from atoms there. Now, understand the importance of dual nature of matter and atoms topic, particularly in 2025, which is supposed to be one of the slightly different and difficult paper there. There are as many as 5 questions under the heading of atoms and dual nature. You can see the questions here. This is one question based on the atoms there. And these are the questions from atoms and dual nature. As many as 5 questions they have given in physics. You know that these topics are common topics both in physics as well as in chemistry. Okay, most probably put together in physics and chemistry in 2025 might be around 6 to 7 questions. So that is a definitely huge marks there. So these are the scoring topics in both the subjects there, and I'm sure you take the advantage of our classes. Okay. Now, in the topic like atoms, you need to be very thorough with the formulae there. What I have noticed is students remember the formula in one particular way only. Not just one way is enough there. You have to remember the formula slightly the other way. What is the meaning of slightly other way? 100% I will explain there. Listen carefully. Okay, now the complete atoms concepts which are required for the entrance exam, we have put it into 2-3 pages. And we need to be slightly slow when we discuss these points. Now listen carefully. Okay, now Bohr's model of hydrogen atom is applicable for atoms having only single electron. Okay, for example, an atom like copper may be having 29 electrons there. You have to send all 28 electrons out of the atom there, and you have to retain only one electron. Those are said to be single electron system. So Bohr's model is readily applicable for single electron system only. Okay then. Now, what are the concepts that are required right under this particular one? Not just formulae there. Some basic concepts are all the time needed. It is the first point like this. Whenever the electron is revolving around the positively charged nucleus in a circular orbit of radius r with some velocity like v there, this is the electron orbiting around the nucleus in a circular orbit of radius r with a velocity v, and it is orbiting in the nth orbit. Okay. For every particle to perform circular motion, it requires a centripetal force. Who will provide the centripetal force? This electron will experience the electrical force of attraction towards the nucleus. The negatively charged electron experience electrostatic force of attraction towards the positively charged nucleus, and this particular electrostatic force of attraction is being converted as centripetal force. That's a concept number 1. Okay. Bohr's model is based on one of the important hypotheses that the angular momentum of the electron is mvr, nothing but nh by 2 pi. Whenever the electron is orbiting in any orbit, its angular momentum in that particular orbit will remain constant. That angular momentum is mvr, nothing but nh by 2 pi. Now we have to combine these 2 points there to get the equations for radius, velocity, energies, and so on. What are the equations that are required? Now, many of the students remember that radius of electron orbiting in the nth orbit is given by 0.53 n squared by z angstroms. This particular formula generally almost all the students are thorough with. Not only you have to remember the formula in terms of this 0.53 into n squared by z, you have to remember the formula from the letter notation. Okay, radius of electron in the nth orbit is nothing but epsilon naught n square h square by pi m z e square. So epsilon naught n square h square by pi mz e square. Writing all these constant values there, epsilon naught value, h value, mass of the electron, charge of the electron there, you get a 0.53. So radius of electron in the nth orbit comes out to be 0.53 n squared by z. That you have to definitely remember, plus this formula there, epsilon naught n square h square by pi mz e square. There are many entrance questions in the last decade there which were testing whether you know this complete letter notation formula or not. I will show you. Okay. Then similarly, velocity of electron in the nth orbit is 2.18 into 10 to the power of 6 into z by n meter per second. That is a numerical formula there in terms of 2.18. You have to remember, even in the letter notation. In the letter notation, it comes out to be z squared by 2 epsilon naught nh. This is a formula, z squared by 2 epsilon naught nh. Okay, you have to be good at these things. Okay, what is the formula for kinetic energy of the electron? All of you know, kinetic energy is half mv squared, and here it comes out to be z squared by 8 pi epsilon naught r. Okay, what is the electrostatic potential energy? Minus z squared by 4 pi epsilon naught r. And total energy is given by this formula there. So you have to be very good at it. All these things, all these formula, you need to be thorough with. Okay, absolutely you have to be thorough with all these formulae. Okay, what is the total energy of electron in the nth orbit? Total energy of the electron in the nth orbit comes out to be minus 13.6 into z square by n square in terms of electron volts. Minus 13.6 into z square by n square electron volts. This 13.6 itself is known as, the 13.6 eV is known as Rydberg. Rydberg constant different, Rydberg different. 13.6 eV is known as Rydberg. Okay, one of the NCERT wordings are there, and that Rydberg is the product of RHC. R means Rydberg constant, H is the Planck's constant, C is the velocity of light. When you multiply RHC, you will be getting the Rydberg nothing but 13.6 eV. So you need to practice this particular page too many times. Okay, then coming to the next set of things here, there, pay attention. What is the energy of electron in different orbits there? So just now we have seen that total energy of electron in any nth orbit is given by minus 13.6 into z squared by n square ev, nothing but minus rhc into z squared by n square ev. So you have to know the formula numerically and as well as in letter notation. Both the things you have to be good at. Okay, now you know what is the total energy of electron in any nth orbit. So particularly I am talking about hydrogen atom whose atomic number is 1. So put z is equal to 1, the total energy of electron is minus 13.6 by n square ev. Okay, what is the energy of electron in different orbits? When the electron is in the ground state, we say that its orbit number is 1, ground state, orbit number 1 there, and orbit number 2 to infinity, they are said to be excited states. So orbit number 2 corresponds to first excited state, as every one of you know. Orbit number 3, second excited. Orbit number 4, third excited, and so on. Now, it is very, very, very essential for you to little memorize these values there. No other way. Okay, 2 questions will tell you that particular point like anything. Must. Okay, total energy of electron in the nth orbit is minus 13.6 divided by n square ev. Now, I want to know what is the energy of electron in different orbit states there. Okay, here in the first orbit, minus 13.6 by 1 square, minus 13.6 ev. In the second orbit, minus 13.6 by 2 square. So minus 3.4 you get. Similarly, the energies of electron in different orbits you have to be thorough with. In the ground state, minus 13.6 ev. The orbit number 2, minus 3.4, minus 1.51, minus 0.85 in the fourth state, and so on. You have to remember it. You have to little bit memorize these things. Yes. Now, not only that, the difference between the energies of the successive orbits there. What is the difference in these two energy levels means 10.2 eV. Here it is 1.9 eV. Here it is 0.6 eV. Now, those students who are aiming for almost full marks, then they even remember these things for them to be most comfortable in answering the questions there. They say the question and immediately answer. Okay, now what is the energy difference between the ground state to third state there? N is 1 to N is 3. So this 10.2, 1.9 you have to add up, and it comes out with 12.1 eV. Okay, then this is 12.1 eV. Okay, now one small point is that as you are going from orbit number 1 up to infinite orbit there, as you are going up there, you can see that the energy is from minus 13.6, it is becoming 0. Minus 13.6 eV to 0 means as an increases, energy of electron increase. Energy of electron increase, but what will happen to the energy difference between the successive orbits? Energy difference between the successive orbits. So energy of electron is suddenly increasing from minus 13.6 eV to 0. But energy difference there, you can see that here the energy difference 10.2, here it is 1.9, here it is 0.66. The energy difference is decreasing. Okay, so depending upon the way they ask the question, you have to answer that point there. Listen. Okay, all of you know that any electron in the higher orbit will have higher energy, lower orbit will have lower energy. When the electron jumps from higher orbit to lower orbit, it will be losing the energy in the form of electromagnetic radiation, in the form of photons there. And the loss in energy of electron is nothing but energy of the emitted photon. And what is the wavelength of emitted photon? Everyone must be knowing that 1 by wavelength of emitted photon is nothing but Rz square into 1 by n1 square minus 1 by n2 square. N1 is the lower orbit number, N2 is the higher orbit number, and these are the basic essential points there. So, good number of formulae will be there, but most of the formulae you are good at. Only care you have to take is that not only numerical formula you remember, like 13.6, you have to remember even RHC. Both the things you have to be good at. Okay, now listen carefully. Okay, only one particular point I explain about something like the spectral lines there. Whenever the electron is jumping from higher orbit to lower orbit, it will be losing the energy, and the energy will be converted in the form of photon there of some radiation, some wavelength. Okay, when do we get Lyman series? Means when the electrons in the higher orbits finally land and jump to the orbit number 1. When the electrons come to the lowest orbit, orbit number 1, you will be having the Lyman series. Under the heading of Lyman series there, when the electron is jumping from 2nd to 1, you get the first line of Lyman series, L1. So you know that 3 to 1, second line, L2. When it is jumping from infinite orbit to the first orbit there, you get the last line. That last line is known as series limit. Last line is known as series limit. In the NTA conducted exam, they were using the term series limit too often. So the first line means 2 to 1. The last line of Lyman series means it should be coming from infinity orbit to the orbit number 1. That is known as the series limit. Okay. Similarly, you know, in the case of Balmer series there, the electrons have to finally come to the second orbit there. They have to jump to the second orbit. 3 to 1, first line of Balmer. Infinity to 2, that happens to be the second line of Balmer. So these are the Lyman, Balmer, Paschen, bracket. All these are generally most familiar to you there. So we need not spend more time for it. But you have to just have some idea about these points which you have. Okay. Now, some very good questions are being, we are going to discuss right now there. And on a piece of paper, if you try the questions and get the answer, it will be excellent there. And please try for it. Okay then. Yeah. The first question. Angular speed of electron in the first excited state of beryllium triple plus ion is dash. Okay, the angular speed of the electron in the first excited state of beryllium triple plus is dash. Okay, all of you know that beryllium triple plus has a single electron, so we can use the Bohr's model of hydrogen atom concepts formulae very readily, very fluently we can use. Okay, then what are the basics that are required for it? So I have written those points so that you think yourself and you start doing there, then say. So the first thing is that it is a combination of Bohr's model plus the circular motion. Okay, so whenever any particle like electron is orbiting in a circular orbit of radius r, with a speed v and an angular velocity omega. What the basic equation that connects them is v is equal to what? Come on, tell me. R omega. This is the first thing there. So v comes out to be R omega. He is asking the angular velocity or angular speed. Omega means both angular velocity as well as angular speed there. So we want to know what is the angular speed there. Okay. Now, the simple point, the only thing is you have to be good at the formulae recollection, good at the units and so on. So to begin with, what is the atom given in the question? Just a fundamental question to begin with. Okay, so that every one of you get the answer definitely and be confident about. What is the atom given? Beryllium triple plus. What does it imply? Its atomic number comes out to be exactly 4. Hydrogen, helium, lithium, beryllium, 4. It is said to be first excited state. Not first orbit state, first excited state. All of you know, first excited state means the orbit number in which it is orbiting is 2. All of you know, this is the ground state and the remaining are excited states. So excited state 1 means, ground state means 1, first excited state 2. Okay, that is also a familiar point. Then I want to know how to calculate the angular velocity. What is the velocity of electron in any nth orbit there? This comes out to be 2.18 into 10 to the power of 6 into z by n. So velocity of electron is 2.18 into 10 to the power of 6 into z by n. Okay, just intentionally just going to that particular point there. So you have to be good at these things. 2.18 into 10 to the power of 6 z by n and the other one. Okay, now coming to the next step there, listen. So here this is the velocity of electron. Then the radius of electron in the nth orbit comes out to be what? Come on, of you, 0.53 into 0.53 angstroms. I am converting the angstroms here there into 10 to the power of minus 10 into n square by z. Okay, there's the radius of electron. Now you want to find the ratio between these things, the ratio between these 2 points there. So to begin with, the angular velocity is equal to, this is 2.18 into 10 to the power of 6 divided by 0.53 into 10 to the power of minus 10 into, this comes out to be z by n. When you divide these things there, this z will come to the numerator there. So this comes out to be z square divided by n cube. So just divide one with the other there. So you know that angular velocity omega is equal to, angular velocity omega is v by r there. V is equal to r omega, already we discussed. Omega comes out to be v by r there, and you know v as well as r. Rest of the things are straight away there. So this comes out to be 2.18 by 0.53 into z square by n cube. Now I am writing the value of this z square. Z square comes out to be 16. N cube means 8. Z square 16 by 8. So this complete term in the next step it comes out to be 2. This comes out to be z square, okay, is 16 divided by n cube is equal to 8. It comes out to be 2. So rest of the calculations you can do. When you are doing this particular calculations there, you can take the little bit of liberty. If the options are too far away there, then you can take 0.53 almost close to 0.50. If it is 0.50, half, that is comfortable. You can take 0.53 a little bit comfortably there, and 2.18, almost 2.2 you can do, and you can finish off the arithmetic just easily. Okay. For hydrogen, for hydrogen-like atoms of atomic number Z. So atomic number is said to be Z. It is not hydrogen-like atom. For hydrogen-like atom of atomic number Z, with the electron orbiting in nth orbit, I want to know what is the ratio of mod of the energy of the electron, modulus of energy of the electron, into velocity of the electron by r. This mod of E into V by r, this complete ratio is proportional to the orbit number to the power of x, z to the power of y. I want to know what is x plus y. I just re-repeat there. This is a hydrogen-like atom. So it can have any atomic number z. Okay. Then the next thing is that it is orbiting in some orbit number n. So it will have some velocity, some radius, some energy. I want the product of mod of the energy into velocity by r is proportional n to the power of x into z to the power of y. What is x plus y? Okay. In the slightly difficult paper being expected there, definitely such a question find its value. Then say, what is the required thing? What is required here means mod of the energy of the electron into velocity by r. First of all, what are the basics that are required? What is the formula for energy of the electron? Energy of the electron, everyone knows that the energy of the electron comes out to be, see here, minus 13.6 into z square of 2 power of 6 by n orbit. You can say 0.5 of minus 10 into square by z. These are the equations you are good at. Radius of electron. Okay, then say, now I want to know what is the mod of the energy there, mod of the energy. So when you are talking about mod, this minus sign, when you are taking the mod of this minus sign, it comes out to be plus there. And you know that energy is directly proportional to z square by n square. 13.6 is a pakka constant there. So I can remove the constant by proportionality sign. So energy is proportional to z square by n square. In place of energy, you have to simply write proportional to z square divided by n square. Okay, what is the velocity of electron? Velocity of electron is directly proportional to z by n. So here you have to write this velocity is nothing but z by n. The constant term you have to replace by proportionality sign, z divided by n. Radius there. So here it comes out to be r is proportional to what? Come and tell me. N squared by z. So this is n squared by z. See here. This is mod of E into V into 1 by R. You can see that this is 1 by R. R is proportional n square by Z. 1 by R means you can happily write Z by n square. So mod of E into V into 1 by R. So R is proportional n square by Z. 1 by R means Z by n square. Yeah, if you happen to see it, this comes out to be directly proportional to Z square into Z into Z. So it comes out to be Z to the power of 4 by n to the power of 5. So these are the things there. So this comes out to be z to the power of 4 by n to the power of 5. So what is the required ratio here means the required ratio is nothing is proportional to z4 by n5. What is said in the question there? This is nothing but we can write as z to the power of 4 into n to the power of minus 5, n to the power of minus 5. He said that this particular required ratio is directly proportional to, first I am writing this one, z to the power of y. What is said in the question? Z to the power of 5 into n to the power of x. Yeah, we got the only thing is, you have to be damn good at this formula. You have to know that the constant terms can be replaced by proportionality sign. Yeah, so after doing these things, the required ratio we got it as z to the power of 4 by n to the power of minus 5 we got there. Then this you compare with the equation given z to the power of 5 n to the power of x there. So we can say that x comes out to be what? Come and tell me. Minus 5 and y comes out to be, okay, if you compare there, x is minus 5 and y is equal to 4. Okay, when once you know x and y there, you can simply calculate x plus y there. It comes out to be minus 1. Okay, the question slightly newly being can be asked in the coming entrance, and you have to be good at. Okay, in Bohr's model of hydrogen atom, the orbital radii of orbiting electron in the nth, n plus 1th and n minus 1th orbits are given like this. What is the radius of electron orbiting in the nth orbit means Rn. In n plus 1th orbit, Rn plus 1. Here it is Rn minus 1. Okay. And these three radii are related by some relation like this. Okay. The question is 100% simple. Only thing is little bit of concentration needed for you in the exam hall to crack the question. So this particular relation is given. I want to know what is the energy of electron in the n minus 2 orbit. The two in terms of not electron volt, but in terms of joules. Okay, so while reading the question, you should have clarity. Now, starting with the first point, hydrogen atom it is given. What do you mean by hydrogen atom? Atomic number is 1. What are the things that are required? He is talking about radius. What is the formula for radius of electron in the nth orbit means 0.53 into n squared by z, so many angstroms there. In terms of angstroms there, this is 0.53 into n squared by z angstroms. Okay, now somewhere here we are interested about the energy of electron. Energy of electron means total energy. So total energy, you know the formula there. Okay, minus 13.6 into z squared divided by n squared electron volts. Okay, these are the two things that will happily give the answer for you. Point number one. This particular equation is given intentionally to slightly frighten you, very slightly frighten you. You shouldn't. So, from this particular equation that is given, Rn plus 1 minus Rn by Rn minus 1 is 1. You just cross multiply. You just cross multiply. So, what you get here means radius of electron in the n plus 1th orbit minus radius of electron in the nth orbit is radius in n minus 1th orbit, naturally. Okay, these are the things. Okay, now in what way radius of electron in the nth orbit is to be written there? Intentionally I am writing radius of electron in the nth orbit in terms of this angstroms there. So this is 0.53 into n square. Already Z we have seen it as 1 there, this one. So in the nth orbit it is n square. Radius of orbiting electron in the n plus 1th orbit comes to be 0.53, n plus 1 orbit now, n plus 1 whole square. Okay, in n minus 1th orbit comes to be 0.53 into n minus 1 whole square. Nothing we have done, absolute nothing. Radius of electron in the nth orbit, you know perfectly. If it is nth orbit, n square. N plus 1th orbit, n plus 1 whole square. N minus 1th orbit, n minus 1 whole square. Okay, now the simple arithmetic says that if 0.53 can be taken common and it can be cancelled. Here comes the formula, n plus 1 whole square. It is just like a plus b whole square, a square plus b square plus 2ab, n plus 1 whole square. So here it comes out to be n plus 1 whole square. This is n square plus 1 plus 2n minus of n square is equal to n minus 1 whole square. So n square plus 1 minus 2n. Just recollecting the a minus b whole square formula. What is the next step then? This n square, okay, then this is this n square can happily be cancelled. This n square can be cancelled. Okay, then you can cancel this one with this one. So here you get n square minus 2n. I am writing this term first, is equal to 2n. Yeah, n square minus 2n is 2n. Some students think they may end up with quadratic equation. Nothing like that. Very simple solution. Very simple solution. And if you happen to see it there, as the next step here, I am writing, then this, here it comes out to be n square is equal to, I am writing the equation once again, n square minus 2n is equal to 2n. So here it is, n square is equal to 4n. So nn get cancelled. The orbit number is equal to 4. N is equal to 4. Okay. He is not asking n actually. He is asking what is the energy of electron in the n minus 2 orbit. When n is 4, what is the n minus 2 orbit means? N minus 2 happens to be 2. You want the energy of electron in the second orbit there. You want the energy of the electron of the hydrogen atom in the second orbit. You are thorough with the energy of the electron here there. So this comes out to be minus 13.6 into z square, already hydrogen atom. So that is 1 square divided by, we are talking about second orbit. So it is n square. N square means it comes to be 4. When it is in the second orbit, that orbit number square comes here there, minus 13.6 into z square by that orbit number square, 2 square 4. So if you just simplify there, you end up with the answer of minus 3.4 EV. The first tempting answer in the exam paper will be, they give minus 3.4. But the answer is in EV, electron volt. You have to catch that it is being asked in terms of joules. Then you recollect, how do you convert electron volts into joules? 1 electron volt is nothing but 1.6 into 10 to the power of minus 19 joules there. You have to do this simple simplification, and which comes out to be close to 5 there. So 5 into 10 to the power of minus 19 joules, close to that answer you will be getting. Okay, depending upon the options, you can just pick up the proper option. Okay. Okay, in Bohr's model of hydrogen atom, electron is initially orbiting in a second excited state. Now, okay, now it is jumping from a second excited state to the ground state. The electron is jumping from a second excited state to ground state. What is the percentage change in the centripetal force experienced by the electron? As already I have put the little bit of title place, it is a combination of Bohr's model of hydrogen atom plus electrostatics. Okay, generally examiners like any simple question but dealing with two concepts so that they can test more number of concepts in a meaningful way. So two simple concepts you have to use together to get the answer for this question. Reasonably decent question for this entrance exam system. Okay, in Bohr's model of hydrogen atom, electron is orbiting initially in second excited state. By now, everyone knows that second excited state means the initial orbit number in which it is orbiting is 3. After ground state, first excited, second excited. So naturally, second excited state means 3. Okay, from that it is coming to the first excited state, ground state. Ground state means orbit number is 1. Ground state it is coming. So orbit number 1. When the electron is jumping from 3 to 1, so its centripetal force will change. Its centripetal force will change. For then, what is a percentage change in the centripetal force? So the basic concept in this particular question is that already we were discussing at the beginning of the class. For any electron to perform circular motion, it requires a centripetal force directed towards the center, and that particular centripetal force is nothing but the electrical force experienced by it. The centripetal force is the mod of the electrical force experienced by it. What is the formula for the electrical force experienced by it? So 1 by 4 pi epsilon naught into charge of the electron into charge of the nucleus divided by r square. Whenever you want to calculate percentage change in force there, okay, that particular centripetal force nothing but F. The centripetal force is provided by electrical force, and electrical force from electrostatics, 1 by 4 pi epsilon naught q1 q2 by r square. Yeah, 1 by 4 pi epsilon naught. Q1 means charge of the electron, Q2 charge of the nucleus by r square. Now, in this equation, ask what are the constant terms here there. You know that 1 by 4 pi epsilon naught is a constant. Charge of the electron, charge of the nucleus are constants. Electron may be jumping from higher orbit to lower orbit. Definitely its radius will change, but charges of electron and nucleus same. Here comes the next basic point. Now we have to say that the force, nothing but the centripetal force, is inversely proportional to r square. Now, if you recollect, what is the radius of electron in the nth orbit there? So 0.53 into n squared by z. Here 0.53 constant. Same hydrogen atom, Z is 1. Okay, it says that R is proportional to n square. Yes, R is proportional to n square. Now, F is proportional to R square. In place of R, we can write n square whole square. I intentionally repeating this point. Force is proportional to 1 by r square, but r is proportional to n square. I repeat again, please. Force is proportional to 1 by r square, and r is proportional to n square. So r square means n square whole square. Generally, many very good hardworking students forget to second time square it. That's why I was emphasizing 2-3 times. So now force is directly proportional to 1 by n to the power of 4. Rest of the things are little routine there. F is proportional to 1 by n to the power of 4. Then F2 by F1, final force by initial force means final by initial means the initial principal quantum number divided by final principal quantum number whole to the power of 4. F2 by F1 means inversely proportional to n to the power of 4. F2 by F1 means you have to write initial quantum number divided by final quantum number whole to the power of 4. What is the initial quantum number there? It is in the third excited state, 3 by 1 whole to the power of 4. This comes out to be 81. In any topic of physics, percentage questions are quite common there, very quite common. Then you want to know what is the percentage change in the centripetal force there. What is the formula for percentage change in force? You know the formula. Percentage change in anything means final by initial minus 1 into 100. I repeat, final by initial minus 1 into 100. Percentage change in the force comes out to be F2 by F1 minus 1 into 100. Okay, what is F2 by F1 we got? 81 minus 1 into 100. So the answer comes out to be as much as 8,000%. This is the perfect answer for the question. The percentage change in the centripetal force experienced by it is 8,000%. Okay. The next question. Electron in the ground state of Bohr's model of hydrogen atom. While reading the question only, every point should go to the brain. The electron is in the ground state. The electron in the ground state of a hydrogen atom is absorbing specifically 12.1 eV of energy. So I have put it in a different color. The electron in the ground state of hydrogen atom absorbs this much energy. Again, another question of percentages. I want to know what is the percentage change in the angular momentum of electron. So all these questions are coming to you after thoroughly analyzing so many important questions that have come in the entrance examination system over the decades. Okay, electron in the ground state of hydrogen atom absorbs 12.1 eV of energy. What is the percentage change in the angular momentum of the electron? Okay, now a slightly logical question. You need to be having a proper method to do the question. Without a proper method there, the solution will become very lengthy, very, very lengthy. Okay, see here. Now, this is an electron in the ground state. When the electron is in the ground state there, what is the energy of the electron in the ground state means? Everyone knows, specifically minus 13.6 eV. Okay, now this electron is absorbing specifically 12.1 eV of energy. Okay, at the beginning of the class, I was telling you that many hardworking students will be remembering a set of values there to have the real benefit there. So that point I can explain right now. See here, intentionally going back to the back pages there. So it is here there. Listen. Suppose the electron in the hydrogen atom is having an energy of minus 13.6 eV. Okay, now these energies you have to be good at is, you have to remember, you have to practice these things. When this electron having the energy of minus 13.6 eV absorbs 12.1 eV of energy, directly it jumps to what state, come out of view? The third state there. From minus 13.6, it will be jumping to the third state. So coming back to the things here there, listen. So more important version of this one will be the very next bit, just listen. So the electron is in the ground state. It has energy minus 13.6 eV. Now it is absorbing 12.1 eV of energy. As we have seen there, the energy of the electron, after it absorbs 12.1 eV of energy, it is going to the third orbit there of a principal quantum number comes out to be 3. The initial quantum number is 1 and final quantum state is 3. I want to know what is the percentage change in angular momentum. Okay. Angular momentum is nothing but MVR, nothing but NH by 2 pi. Angular momentum is MVR, NH by 2 pi. Now ask yourself, what are the constant terms? H is a constant, 2 is a constant, pi is a constant. They are pakka constants. Angular momentum is directly proportional to n. Okay, now we want to know what is the percentage change in angular momentum. As we have seen already there, the percentage change in angular momentum is nothing but final value by initial value minus 1 to 100. So final value L2 by L1 minus 1 into 100. Percentage change in angular momentum. To calculate the answer for percentage change in angular momentum, anyone need to calculate L2 by L1. From that, subtract 1 and multiply with 100. Now, L is proportional to N. It does imply that L2 by L1 will become N2 divided by N1. You know, N2 is 3, N1 is 1. So, L2 by L1 is 3. 3 minus 1 into 100. It is a perfect 200% answer there. So this is the answer here, 200%. Now, whatever concepts are being explained right here, there, those points you have to well use right in this particular question there. Okay, here the method is important. Okay, here you have to follow a proper method and you need to be logical and you need to be alert while reading the wordings in the question. Okay, pay attention. In Bohr's model of hydrogen atom, electron is orbiting in a particular excited state A. It is not in the ground state. It is in some excited state. Ground state means orbit number is definitely fixed, 1. Excited state means starting from 2, it can be anything up to infinity, starting from 2. So you have to decide what excited state. When this electron absorbs 2.56 eV of energy, it reaches another excited state B there. I want to know what is the final velocity of the electron, find the velocity of electron in the excited state B. Now you have to understand the electron is going from one excited state to some other excited state. From one excited state to other excited state, we want to know what is the velocity of electron in the final excited state. Now, if you just recollect the things here, there, in which case the 2.56 eV of energy can be absorbed. So listen, electrons cannot absorb whatever energy comes in their way. They can absorb only specific quantities of energies. So remember that this is 1.9 eV from here to here, 0.66 eV. The electron can absorb 1.9 plus 0.66. That means 2.56. 1.9 plus 0.66. 2.56 eV of energy it can absorb when it is going from only the second state to the only when it is going from second state to the fourth state. When the electron is going, here 1.9 plus 0.66, 2.56 eV of energy can be absorbed in one and only one situation there, never in the other case, when it is going from second orbit to the fourth orbit. So this is the method, this is the simple logic, this is the way a good student will do there to definitely get the mark in time. So electron must be going from the second orbit to the fourth orbit. So directly they will come to the conclusion that the final orbit in which the electron is existing, the final orbit in which the electron is existing is 4 there. So the final orbit is nothing but 4, and you want to know what is the velocity of electron in that final orbit there. You know the formula for velocity of electron, 2.18 into 10 to the power of 6 into Z by N there. It is said to be hydrogen atom, Z is 1, and you know N is 4. So you'll get the answer in terms of meter per second if you write N is 4. Okay. Then see here. Angular momentum of electron in Bohr's model of hydrogen atom is h by pi. Now it is absorbing certain energy and jumps to the excited states where the angular momentum is 2h by pi. What is the percentage change in time period of revolution of the electron? So the question appears to be 100% simple till this black dot there, till this dot, it looks simple. Suddenly the word is got changed to the reading there, my dear friends. See here, percentage change in the time period of revolution of that orbiting electron. Very good question. The examiners can pick up. Now see here. So coming to the first point there, listen. First, what is the initial angular momentum of the electron? The initial angular momentum of the electron is nothing but h by pi. All of you know what is the formula for angular momentum there? Angular momentum is nothing but nh by 2 pi. The initial angular momentum means you have to write n1. All of you know angular momentum is nh by 2 pi. Initial angular momentum is n1 h by 2 pi. Pi get cancelled, hh get cancelled. So n1 comes out to be n1 comes out to be 2. That's the first point. The initial angular momentum is given as h by pi. From that, the initial orbit number you got. Now, this electron is absorbing the energy and thereby jumping to the higher orbit where the angular momentum has freshly become 2h by pi. Okay, what is the new angular momentum one day? N2 h by pi. Angular momentum is nh by pi. Na? So L2 corresponds to N2, this one. Once again, h by pi. Okay, the angular momentum is nh by pi there. Then you can see that h by pi term, only 1 second please. Yeah, h by pi term get cancelled. N2 comes out to be as much as 4. That means the electron is jumping from second orbit to the fourth orbit. He is not asking the number of orbit shift. He is asking what the percentage change in its time period of revolution. Immediately, you have to recollect that let it be a satellite orbiting around a planet in gravitation topic or electron revolving around the nucleus in atoms there, both are one and the same. So in both the cases, you know that the square of the time period is directly proportional to r cube. You know Kepler's third law. T square is proportional to r cube, equally applicable for electron system. Okay, now come on, tell me, T square is proportional to r cube. Here you have to be careful. You have to recollect one of the formula we used good number of times here. So radius of electron in the nth orbit is 0.53 into n squared by z, so many angstroms. Here z is constant 1, 0.53 is constant, r is proportional to n square. So T square is proportional to r cube. R is proportional to n square whole cube. So T square is proportional to n to the power of 6. Every one of you must be knowing this powers can be cancelled here, there is 100%. Then T is directly proportional to n cube. T is proportional to n cube. Okay, once again, I want percentage change in time period of its revolution. Now, you can calculate what is T2 by T1 cube. Percentage change in time period means final value by initial value. Final time period by initial time period minus 1 into 100. So T2 by T1, you know 8. 8 minus 1 into 100. It is a 700% answer. Okay. Now comes wavelength of emission spectrum line of a Balmer series of hydrogen atom is Z, is lambda. Wavelength of emission spectrum line of the series limit of Balmer series of hydrogen atom is lambda. Find the frequency of photon emitted when second line of bracket series of helium plus is emitted, that too in terms of lambda mu naught epsilon naught. Okay. Such questions are most common in both chemistry and physics there, and this question covers almost all the possible models that they can ask. See here. Now it is a simple but important comparison between the two things there. Okay, in the first case there, he is talking about the hydrogen atom. So this is the hydrogen atom we are dealing here there, and here we are going for the helium plus ion, helium plus, comparison of two cases. Okay, now in the first case, he is talking about the series limit. Is many times they are using this wording, series limit. That too, the series limit of Balmer series of the hydrogen atom. Okay, now every one of you in the class know Balmer series there, the initial orbit number comes out to be 2. Lyman Balmer. Okay, Balmer 2. Series limit means the final orbit from which the electron is jumping is infinity. Series limit means the ultimate line, last line. So from infinity it need to jump. Okay, and for this particular one, wavelength is given as what? Come on, tell me, lambda. That's the first step. How do we use this data there? Here the formula you must be recollecting from the things we have done, and you know is 1 by lambda is equal to rz square into 1 by n1 square minus 1 by n2 square. Proceeding further, so this is 1 by lambda itself is given as lambda, or hydrogen atom z square means 1 into 1 by n1 square, 1 by 4 minus 1 by n2 square is 1 by infinity. So this comes to be 0. So here comes the point that lambda is equal to 4 by r. Lambda is 4 by r. This is the first step. Okay, now we want to know not wavelength. The question is being slightly modified there. Okay, find the frequency of photon emitted by second line of Balmer series there. This is the second line of the Balmer series. Okay, all of you know. Okay, so the second line of bracket series, the second line of the bracket series. Okay, so coming to the point, as far as the bracket series is concerned there, all of you know, the lower orbit to which the electron has to jump is 4. We are talking about second line. So the lower orbit is 4. The higher energy levels happen to be 5 and 6. 5 to 4 means first line. 6 to 4 is the second line. So the higher orbit number comes out to be 6. This is the first line. This is the second line. Second line corresponds to the higher orbit number 6. The electron will be jumping from the orbit number 6 to 4. Lower orbit number 4, higher orbit number 6. How to calculate the wavelength right in this particular case? 1 by lambda dash is same formula you need to use, R z square. Okay, this is helium. So atomic number 2, R z square into 1 by N1 square, 1 by 16 minus 1 by N2 square, 1 by 36. Okay, from this 1 by lambda, okay, 1 by lambda dash is equal to, in place of R, you can write, okay, in place of R, you can write happily 4 by lambda there, as we got here there. R is equal to 4 by lambda into 2 square comes to be 4. This 4, if you cancel, this is 4 into, okay, 1 by 16 minus 1 by 36. Okay, from these things, anyone can happily do the simple algebra and calculate lambda dash. We can calculate lambda dash. But he is not asking lambda dash. He is not asking lambda dash. He is asking the final frequency. Every one of you in the class know that in what way frequency and wavelength are being related. So you know that velocity of any electromagnetic wave or any wave is V is equal to N lambda. In the case of electromagnetic wave, the velocity of the electromagnetic wave we represent by C. C is equal to this, the final frequency we are getting N dash into lambda dash. Okay, you want final frequency. So N dash comes out to be C by lambda dash. Do you know lambda dash means? Yes, we do get lambda dash from here, there. And how do we get C? How do we get C means, okay, what are the terms that are given? Mu naught epsilon naught. You know that velocity of any electromagnetic wave comes out to be 1 by root mu naught epsilon naught. So one of the important formula in 2S physics, velocity of any electromagnetic wave comes out to be 1 by root mu naught into epsilon naught. So mu naught epsilon naught are given. So from that you can write C there. From here you get lambda dash. If you substitute, you do get the answer for the question. So this is a slightly twisted question at the end there. Okay. We do the one last bit here there and stop the class. Pay attention. It is a combination of atoms plus rotational mechanics. Okay, absolute nothing is there, but you need to think a little bit to get the answer for the question on your very own. You can do it. Now, electron in Bohr's model of hydrogen atom makes transition from third orbit to first orbit in 6.64 nanosecond. Electron will be jumping from higher orbit to lower orbit. And to jump from third orbit to first orbit, it consumed this much time. I want to know, during that particular stage, what is the torque experienced by the electron during this time? Okay, for example, never we have done this particular question in our life, whatever is the reason. The question has come fresh in the entrance exam. Do we get afraid means? Definitely not. That particular tension will be there for everyone, but you control yourself and think. He is talking about torque. Now, I am writing the second step first here, the second step. In what way torque is being defined? Torque is defined as rate of change of angular momentum. You know that force is equal to rate of change of linear momentum. Torque is rate of change of angular momentum. So the angular momentum divided by time. So time interval he has given. Okay. Now you have to calculate change in angular momentum. Can we calculate change in angular momentum means every one of you know that angular momentum of the electron is nothing but what? NH by 2 pi, where h and 2 pi are constant terms. Okay. Now the initial angular momentum means NH by 2 pi, where n is 1. So that means h by 2 pi, n is 1. What is the final angular momentum there? Once again, NH by 2 pi there. So here the electron is in the third orbit, 3h by 2 pi. So I repeat, angular momentum is NH by 2 pi. Initially, N1 is equal to 1, so h by 2 pi. And finally, N is 3h by 2 pi. I want to know what is the change in angular momentum. Change in angular momentum is L2 minus L1 there. 2h by 2 pi, this comes to be h by pi. So the change in angular momentum, you know it as h by pi. And you know the time interval t there, time interval t. Okay. Now, you know the value of Planck's constant, 6.64 in 10 to the power minus 34. You know the time interval, once again given in terms of 6.64, but nanosecond into 10 to the power minus 9. You know the standard value of pi, 3.14. You just substitute here, you get the answer for torque. Okay, when once a new question comes, it is a simple bit, but involving two slightly different concepts. You have to recollect the basic fundamental definition of torque. Just like force is rate of change of momentum from Newton's second law, torque is rate of change of angular momentum, there delta L by T. And angular momentum you are thorough with, NH by 2 pi. So do it and get the answer there. Okay. So I am sure you are definitely using the time well there. So I need not tell you that the exam is definitely fast approaching and most of the students seriously grade up there. And you also, I am sure. All the best, my dear students there, and good luck. Bye-bye.